Swayam Prabha. Digital India. Educated India.
Hello, Namaste. Welcome back to the course. We are in the lecture 4 of the module 2. I did explain in the last class that we will be probably working on GIS data models as such, or looking at GIS data models, but I would first get into how do you collect data, then get into data models. So, I would go stepwise. So, first is how do you collect the data, what kinds of methods you have to follow, where and how you get the data. So, I have given you a lot of sources already that where the data is available, but I'll inform you how the data is collected. And so, when I look at the entire concepts that I would be speaking on in this class, the first thing is look at the GIS data collections. What are different data sources that are there? It may be primary data or the secondary data sources, and how the primary data is efficient and secondary data sources, there are certain issues that has to be counted before you consider secondary data sources to build the data models. Then data sampling methods. So, this is where most of us make a mistake. We do not consider a definitive sampling methods. We do only understand that if this is how it goes, then the sampling can be done, but we should look at how the data is collected in a proper way. So, data sampling methods is extremely important, and the way it is collected, the way you understand your process, then that makes it a different model. Then finally, the secondary data sources, how to handle secondary data sources, also we will look at it in this slides. So, when we look at GIS data collection, so when the most important part of any GIS project is data, the collection of data. So, if you ask any GIS user or any user who is working on GIS data, they would say it's very difficult to get a data. But why it becomes extremely difficult to get a data is probably we do not know the source of data, or we do not know how we actually generate a data, how do we handle the data. So, what we need to understand here is what types of data you can use with GIS. It can be any type of data, but how to evaluate it, how do you actually use it, how do you evaluate it for being a better data. Where do you find the data? So, I have given huge number of examples. Please look at all those websites which I was speaking about in my previous module. So, look at the website that gives you extreme understanding about how data is there. India has huge collection of data. Indian subcontinent can give you huge data sets. So, please look at the data and different sources of data. Then how do you create your data yourself? You can create your data yourself for your project. You do not need to depend on any other sources. So, you have to create it. So, how do you create it? Which means how do you sample it first of all? So, that is what is very important. That is what we would understand in this particular lecture. So, when we always look at, as I said, data collection itself is time consuming, and many of the projects, if you see, data collection itself is a 15 to 50% of the cost in any GIS project. So, if you think about the cost, if you just take out the staff cost, the person who is actually collecting the data, almost 80% of the entire the cost is in terms of data collections, almost 80 to 85%. So, if anyone who is working with GIS will definitely tell you that the data itself is what matters, but you can get data yourself. It may not even cost more, because it will cost more only if you do not know the sources of actually getting the data. So, when we look at data collection is also synonymously referred to as data capture in many ways, data automation, data conversion, data transfer, data translation, and data digitization. These are the different ways of saying how the data is actually used, or data is actually acquired, or data is collected. Okay. So, when I speak about data, there are two types of data. One is the primary data, other one is the secondary data. So, when I say primary data, these are the data that is measured by you through surveys, field data collections, or maybe some of the remote sensing data that you may get in. With advent of UAVs, the surveys and field data collection has become extremely easy. Yeah, and only thing is that probably the government has mandated the use of licenses in terms of UAVs, and only in the specific regions. So, that primary data collection has become extremely easy, but if you have primary data, then your data model representation would be extremely good. So, whenever you are building up a data model, try to collect as much as primary data as possible. That's my advice. So, visit the place. So, there are many examples of various students doing the analysis without even visiting the site, or visiting the place of which they are trying to do, and or mimicking in the data model. If you don't understand the properties of site, if you don't visit a site, if you don't see the site at all, how it is extremely difficult to mimic the same site in the data model. So, the first thing is, look at the data, look at the primary surveys, go to the data, go get the primary data. So, that is extremely important. Next is the secondary data. So, data obtained from existing maps, okay, tables, or any of the other governments. There are huge number of government sources which gives you data. It may be statistically, maybe quantitatively, maybe qualitatively. So, what are the different sources? All of these sources becomes a secondary source. Okay. For example, I have mentioned some of the data sources here. If you look at the raster data model, in the primary source, you have digital remote sensing data, or that is also called maybe a satellite data, or any remotely sensed data, aerial photographs, photographs from UAVs. So, when you look at primary data as a vector data model, you have GPS data collection and surveying data collection that can be in the form of vectors. So, secondary data, when you look at it, scanned maps and topographic maps, I will give you some examples of this. Digital elevation models with maps, that also can be your secondary data for using a raster data model. Whereas, when you are looking at the vector data model, it is more of topographic survey or LIDAR survey and taxonomy and other attribute data from the data sets, from your governmental data sets, or maybe from many of the data sets. If you are trying to gather more information, there are huge number of literatures which can give you certain information on certain data. So, that is a secondary data set that you collect, but always secondary data sets has to be validated, so that you know that information whatever is presented here is correct. How do we know it? Using a metadata. I will come to that a bit later. So, how do we do a data collection? The way the data has to be collected has to be something like this. It is a 5-path process, what I call it as. You have to look at, first you have to plan it. If you do not plan how to collect a data, then you are going to lose on every front of data acquisition. Okay. Then the preparation of a data. So, for example, when I say planning, you should know what every user requires. If you are targeting a certain user set of people who will try to use that tool in order to develop some science, or use that tool to deliver some aspects of applications, you should know what are the user requirements. So, based on those user requirements, you will actually populate the data. Okay. Then available resources, that is extremely important. You cannot go out of bounds to collect the data. Then you have preparation is the next step, where you obtain preliminary data, then look at, if you have collected the data, then you have to look at the data cleaning, which means you are correcting the data for any of the non data sets that has to be there, or you are looking at the noise removal and setting up the entire GIS environment. If you can do certain amount of digitizing and data transfer, that is the next step of how you actually create a data through surveys. So then you have editing and improvement in case there are certain issues. I spoke about offshoots. I'll also show you some of the examples of how errors can be there. So editing and improvement of those specific data has to be done, and most importantly is validation of the data sets. If there are certain data sets which are secondary in nature, please validate that data set. Without validation, never use a data set which can create issues to you when you are actually running the model. And evaluation and final formatting, this is where identifying a process a success or an accuracy assessment becomes extremely important. But when you look at primary data, as I said in my previous lecture, resolution becomes a key consideration when you are collecting any of the primary data, especially in terms of a raster. If you are looking at a raster that is a pixel model, then you are looking at the resolution specifically. When I say resolution, if probably when you look at the raster data model, I will speak about what do you mean by spatial, spectral and temporal. So these are very important in collecting a primary data. So we cannot usually observe the spatial distribution of a variable throughout the study area. So it is, you have to collect the sample data. If your study area is entire KMA, you cannot go every pixel by pixel, every pixel. If you are considering a Landsat 30 meter by 30 meter, you cannot run around with a 30 meter pixel, because it's absolutely impossible to collect the entire data set, even maybe even with 100, 200 or 300 people around collecting the data set. So you have to start sampling. The way you sample, that is what is extremely important. Therefore, when we also collect, they should also capture the actual variation. That is where the sampling becomes very important. So you cannot, if you have a data which is 30 meter by 30 meter, and you say that I will sample at maybe 1000 meter or 2000 meters once, and or let us say it is 10 kilometer by 10 kilometer, one sample I do and another sample at 10 kilometer, maybe 2-3 samples, and I will finish the survey, you may not be able to capture the entire variation in the entire data set. So you have to look at what is the size, what is the resolution of your data, what is the size of your data, how your data is being translated into the data model, then look at what may be the spatial variation that you have to actually capture. So look at all of these properties before you look at how you get into the primary data collection. The very important part, as I am speaking, is the sampling. So when we look at sampling, it determines the density, the sampling density determines the resolution of the data that you collect. Okay. So when we look at a sample that is taken at 1 kilometer intervals, it may not be able to capture anything that changes below 1 kilometer. So if you have something that you have captured in 100 meters or 200 meters, it will be able to give you some changes, the variations in between 100 and 200 meters, but it cannot capture less than 100 meters or 200 meters the way you are trying to capture the data. So look at what kind of capturing of or sampling that you need, what is the smallest size that you have to capture and what is the largest size that you have to capture, what are the different variations in your data set. If so if you are trying to do that, then you have 3 types of different sampling. One is random sampling, and the one is system, and other one is stratified. So we will look at each of these sampling in detail. For example, the first thing is random sample. So every location is equally likely to be chosen. So you can go into any location in the entire Kolkata region, calculate take a sample and populate it. So this kind of sampling can be done when your data set is small, okay, and it is extremely homogeneous. So if you are sampling for different the way of growth of mixed land use and urban land use is there, so you should be able to capture the entire different data points in different data sets properly. For example, if your entire area is just urban area and very minimal change, then maybe the random sampling is the best way to sample it. But if you have mixed land uses all across your region, the way it is not homogeneous, it is completely heterogeneous, then your sampling cannot be a random sampling. Okay. So, normally how people decide which region to be sampled or which point to be sampled is by generating a random number or just like a lottery system. So, the most used method is by generating a random number in the set of selected points. So, the biggest disadvantage, as I explained, is it is not applicable for any large data set. If you are trying to apply it for a large data set, the way you have sampled may really go wrong, or it may not give you certain subgroups that you may be extremely interested in, or some of the users using that particular tool may be interested in. So, that is very important. Then the other way is systematic sampling. So, when you look at this, every sample point are at regular intervals. So, this involves a random start and then proceeds with the selection of every kth element. So, every kth element is from that random sample you decide, it may be third element, fifth element, 10th element. Then how do you calculate k? It is entire population size, which means entire size of how you want to sample. Okay, that is entire the population size that you have considered now divided by the sample size. So, that is extremely important, number of points that you are sampling, okay, divided by your sample size. So, if you are trying to look at this, the main disadvantage that you may come across is it may be very biased. You may be looking at only a specific aspect, but you are biasing your entire data set to understanding only a specific aspect, but the others may not be understood in a clear way. So, for example, to give you a very fair example, let us every 10th registration number and a corresponding student corresponding marks of the student who appeared for the GATE exam. So, it does not mean that every 10 students has scored extremely well or every 10 student has scored extremely bad. So, it is just a kind of sampling. So, it may be biased. So, it may be your intuition that every 10 student is a extremely good student. So, that biasness may should not be there in your data set. But how do you actually remove this biasness is using a stratified sampling. So, but it is very important to understand, it requires a knowledge of distinct spatially defined subpopulation in that entire data set. So, you should know in the entire data set what are the distinct subgroups that are there and how distinct they are and what kind of knowledge you need. If you do not understand that, then you cannot do a stratified sampling. Instead, it is rather better to do a strategic sampling. More sample points are chosen in the areas where higher variability is expected. So, for example, rainfall. So, where the variability is much, you will look at more sampling points. Where the variability is less, you will look at lesser sampling points. So, every unit in this is a stratum has same chance of being selected using the same sampling fraction for all strata ensures appropriate representation of the sample. So, now that biasness is removed, which was there in the strategic sampling, but in the stratified sampling the main disadvantage is that the sampling frame of the entire population has to be prepared separately for each stratum. That is a time taking task, okay. But if done, you can get extremely good sampling points all across your region. It can require extremely large samples. That is what the stratified sampling explains. It needs very big sampling data sets. So, always if someone is interested in extremely clean data, the data that has no bias, then use a stratified sampling, which would actually give you extremely good results. Then coming to the secondary data. Secondary data is more ready-made digital GIS data sets. It may be through the government agencies like the central census, geography, geographical department, or it may be a topographic surveys that has been done, or from the private companies. So, when you look at the secondary data, the first thing that has to be looked at is metadata. As I previously said, metadata is the data about the data. Okay. So, first, what is the procedure that this particular data has been used to collect, different procedures, whether it has been used in the form of sampling or what kind of sampling has been used. Then data lineage, for example, life cycle of that data, how it started, how it has been converted into different forms. Now, what is the way of representation, so that you should know. Then accuracy and the measurement standards, this is also extremely important, what kind of accuracy it has. I did give you a list of examples in the tabulated form. So, all those accuracy and the measurement standards has to be looked at. Then the coding scheme, not every coding scheme is similar. So, look at the coding scheme, how it has been coded. So, that is extremely important. We will also look at some of these coding schemes. So, it has to be required for both spatial and attribute data. So, metadata is available separately for both spatial and attribute data. So, look at both of the look for both metadata in your secondary data. Without metadata, do not use a secondary data. So, that would create problems in your data model. Okay. So, when we look at the secondary data, it can be generated from or converted from various other sources. For example, when we look at the raster data model, when we look at the secondary data, it can be through the scanning of maps, aerial photographs, documents, all this becomes a secondary. Any document, for example, in the government record or a gazetteer, you can scan it and digitize it in order to form a secondary data. Important scanning parameters are spatial and spectral resolutions that you have to look at. The vector secondary data is collection of vector objects from the map bar photographs. So, I'll give you some examples of how it is done. Digitizing manually on a table, or heads up digitizing and vectorization. I will also give you some examples of this in next slides. And photogrammetry, the science and technology of making measurements through a photograph, that also can be a secondary data. So, we can have various secondary data that we can generate, also can get it from the different sources, maybe government or private sources of different applications. For example, when we look at the data sources, we can divide it into three types. One is the framework data, the second one is the socio-economic data, and the third one is the environmental data. When we look at the framework data, so before going into the framework data, I hope many of you would have looked at this particular website, which is called data.gov.in. If not, please have a look at this particular website. It has extremely good data sets, or the data that has been collected over a period of time, and this has been made open for the public. There may be certain data sets which are actually outdated, but these are also extremely important where if you have certain data sets which are old, so that they give you temporal information. So, look at this data.gov.in. there is a huge data set. We also have national data registry, where you can really find out about this data, and also most importantly is whatever data that has been put here as secondary data has metadata. So, whenever you are downloading any data from this particular website, the metadata associated with it can also be downloaded or at least looked at. So, please look at this particular website data.gov.in at your leisure, but please look at it. It is extremely good and very efficient and a good effort from Government of India in terms of sharing the data to the general public. So, when we look at the framework data, as I said, is one kind of data. This framework data is actually a reference data. For example, if you look at this entire map, if I actually give a reference of maybe let us say it is a NH and SH are the state highways and national highways. If I give a reference of NH here, okay, so that becomes a reference data for any of the other observations. So, framework data is basically a reference data that can be used to refer other kinds of data or use it for various other analysis as a reference point. So, that is why the framework data is extremely important in order to develop the entire data set. It can be through topographic surveys, it can be through ordnance surveys, it can be elevation data sets, it can be your contours, it can be rivers, it can be roads, any data that you know exact point is a reference data or a framework data, or maybe intersection of two roads can be a reference data. So these are certain this why the framework data is extremely important in order to for various analysis or building up the extremely good data model. Then you have topographic map. Okay, so it is also called as a topo sheet. Now as of now we have 1:50, 1:25,000, 1:50,000, 1:250,000, 1:1 million maps. So these are actually prepared by Survey of India. So one of those maps is represented here. We look at how these maps are developed, what are different systems, India adjacent country systems, and what are the properties each and every map has, what each of these represent in a map. All of these things we will look at when we are studying about a map. So but as of now, these are the topographic maps also can be used as a framework data, as a source of framework data. So it can be framework data. The digital chart of the world can be a source of framework data. So it largest consistent digital data set for the whole world is 1:1 million. 1:1 million data set is extremely consistent in terms of representing the whole world. So designed mainly for air navigations, not necessarily maybe appropriate for any other users, is 1:1 million data. The next set of data that you have is a socio-economic data. So it can be demographic data, it can be migration data, housing data, food data, transportation data, economic activity data. So these are the data about humans, human activities, and the space and structures to conduct human activities. So this becomes extremely important in your database. So when you are collecting the data, look at, if you have to look at the socio-economic part of it. So these are certain data sets that you may also have it on the government domain that is already available, or you may have to collect it as a primary source. So normally socio-economic data are referenced by, as I said, administrative units. It may be per ward, per district, or maybe per village kind of thing. Then it may be because settlement or villages, as I said. Then individual houses or facilities, if it's a house based service, so it may be individual houses also. So look at what kind of data that you may need in terms of every aspect of collecting the data. So when we have seen this, let me summarize this, but always remember that there are two data sources. The best data source that you can guarantee about to your user is a primary data source. When you look at the secondary data source to populate your database, please look at its metadata. Without metadata, your database is going to be absolutely rubbish. So when you look at we looked at GIS data collection, we also looked at why it is time consuming. I did explain about it is about 15 to 50% of the total project cost it may involve. Then we looked at data sources like the primary data source and the secondary data source, different data sources. I have already spoken about a huge amount of data sources in my previous lectures, please look at it. So then we looked at data sampling methods. We have three types. One is random, systematic, and stratified. Random is used only for the small data sets, whereas systematic sampling can be used for large data set but would be biased. But stratified is the best way of sampling as of now, but the stratified sampling you has huge voluminous work to be done before going into the field. So what kind of sampling is done, please look at it. So that gives you exact way of understanding how the data is generated, how your data is there. Then the secondary data source, you have framework data, you have socio-economic data, you have environmental data. I have not spoken about environmental data. I will give you some examples of environmental data as we progress. So there are huge data sets where we can connect environmental data. I can share it with you over in next classes also. And probably in the next class I will discuss about how you do a data input. So now we have been speaking about digitizers, we have spoke about GPS, how GPS can be an input as a data. We have looked at different ways of inputting the data as plotters, scanners, etc. In my next class I would speak about specific ways of how do you input a GIS data, how do you create a data by yourself, where if you have a reference data. Thank you very much.